Hi guys, today we're gonna learn how to write SQL queries. So we're gonna start from we already learned how to create tables and how to insert data into the table, and that's second part of the uh, practical exercises. We will learn how to write SQL queries now. So I'm going to show you everything from the beginning, how to open the database and how to generate queries one by one as we go through the second part of the class exercises. Um, Let me minimize the video and let's go with the presentation. Okay. So we're going to start from the database that we will be using in class for practice. This database called Chinook database. So it consists of multiple tables, as you can see here. Well, this is a database diagram. So it's part of your Chinook download. So I strongly recommend you guys to look at this database. This The notation is pretty much very similar to what you already know. So it is cross-put notation, but it is enhanced cross-put notation. So on this diagram, you can see one side of relationship, you can see many side of relationship. And if you remember, as we remember correctly from the previous lecture, primary key sits on the one side of relationship and foreign key sits on many side of relationship. So for example, let's look at two tables, genres and tracks. So as you can see that genres sits on one side of relationship and tracks sits on many side of relationship. It means that genre ID is a foreign key in tracks table. So there is many tracks for one genre. And genre is a primary key in genres table. So based on this diagram, you can see where the key sign sits. That's a primary key. You can't see foreign keys on this diagram, but you can clearly identify the foreign key by looking at primary key. For example, in genre, you can see this key sign, genre ID, and then navigating to the next table, genre ID. We know that this table sits on the many side of relationships, so genre ID is going to be a foreign key. Let's look at another example. So, for example, invoice and invoice items. Also, a big point here, guys, this diagram is not complete. So, for example, in the invoice, you can see that invoice has four more columns. So, in order to see all the columns, you actually need to go into the database and look at what columns each table has. But this gives you a very rough idea how the tables are connected together. So, for example, for invoice items and invoice item sits on many side of relationship because gross food is on the invoice item side. Well, we know that invoice item should have a foreign key, right? Because it's on many side of relationship. So we look at invoices that is on one side of relationship, and we can see invoice ID, and invoice ID has a key sign. So we know that invoice ID is a primary key in invoice table, so it's going to be a foreign key in invoice item table. And sure enough, we can find invoice in invoice item table. This comes very handy when we will be executing multiple table queries, which is going to be next class. But for now, please get familiar with the database. Please understand how the relationship works, understand what keys each table has. So just browse the database so you would understand the database structure. Right. Okay. So let's move on with the presentation. So now we're gonna start working. So before we start working, it's a very good idea. Every time you do something to the database, it's a very good idea to take a backup. Right now, we're not modifying the data structure. We're just writing SQL queries. But in the previous part of the exercises, we were creating tables, modifying tables, removing data from the tables. Before you do some kind of manipulations like this, it's always a good idea to take a backup. How do you take a backup? With SQLite, it's super simple. So you just find the location of the file and you copy paste it and give it an exact name. So for example, let me get out of the presentation. Let me find location of my database. So I have various backups here from the last year. So say if I want to take a backup, I just need to get Chinook database that we are working with, make a copy of that, and I probably need to rename it. So every time you take a backup, you want to at least give it a date. So today, for example, is March 3rd, so it's going to be 3/10/2025. And I'm going to give it just like this. In case I did some manipulation to the database, I can always go to this backup. So there's multiple ways to open the database. Well, you can open your SQLite Studio, and then you can open database from there. So you can go to the database and you can add the database. Let's try that. So you can add the database, and then if you're doing it like this, you need to know the actual location of the database. So mine sits on the desktop. I created a separate folder for SQLite, and my SQLite database sits in Chinook SQLite folder. So let me open that and open another one. And here's my Chinook database. So in this case, you just select it. You can double click or you can select it and click select. Okay, so we have a database now. So we are ready to open it. How interesting. Okay, let's test connection. Let's see if I can retry it. Very interesting. Okay, let me try again. Very good. Hmm. All right, so somehow this doesn't work. So what I'm going to do, I'm going to double click on the database. So that's easier. All right. So as you can see, my database opened, but I don't see any windows opened here. Well, a lot of you had this issue, and a lot of you haven't watched videos that I recorded. So the reason why I don't see the database because I don't have my database window open. So I need to go to view, and I need to open the database. So voila, here's my database. Okay, so now it's open, and now you can connect to the database, and now you have your database available for you. All right, let's try again. So let me close the entire window. Let me go to the database, and now Chinook database is available. So when you open the database and database is not there, you need to go to Windows to view, and then you need to enable database window. Okay. Now, we have a database, but in order to see what's inside of this database, you just need to double click on this database. So you double clicked, you have this database called Chinook. We have total of 1, 2, 3, I think 11 or 12 tables, and that's the database we will be using for our queries. There's multiple ways to write a query. So first of all, if you don't know what table you want to query, you can just go to views. You can just go to, I'm sorry, to tools. On tools, you open SQL editor, and voila, you can write any queries you want. So for example, I want to select everything from albums, just like you guys did for your homework B. So I can just start typing. Select asterisk from album. Okay. So albums. Now I can execute that, and voila, here's all my data in the albums. But there's another way to do exactly the same query. So you can right click on albums, you can click generate query, and you can go to select and click select, and it's going to create a query for you. When you create queries this way, you're going to have all the columns that exist in album table. So it's going to show you all the columns. If you don't want some columns, you can just go ahead and maybe delete some of them. So let's say I only want to display album and title. So let me remove two of them and let me execute this query. I don't have data. So what does it mean? It probably means that I have error in my query. So how do I know if my query has errors or not? So if my query doesn't have any errors, I'm going to see prompt something like this, stating that query executed correctly in 001 seconds. If I don't execute query correctly like this time, it's going to show me that there is error somewhere. So in this case, it states error while executing query on Chinook near from. What is sitting near from? Well, it's either albums, right? And we already know that albums is a correct table, but there is also a comma. See, when I removed two more columns, I forgot to remove comma. So now I'm going to remove comma. As you can see, once your query is correct, your table name turns blue. So that's also a good indicator that your query is correct. So SQL is very needy. You need to make sure that you follow instructions. You need to make sure that you don't have extra commas, stuff like this. So say I want to put them on the same page. I'm going to execute them. Voila, I have data. And you can move around your windows any way you want. So you can expand it, make it smaller. But I always recommend to keep your status window open. If you don't see your status window, chances are you need to go to view and enable it. So look, if I disable status window, I don't have status window, so I don't know if my query executes or not. So for example, if I put comma back here, if I run the query, I mean, oh, it still shows me, well, that's something new with the newest update. But if you don't see your status window, the way to bring your status windows back is to go and click status. So I can unclick it not to see it, and then I can click it back and I can see status window. So, all right, my query is correct, but it doesn't really look pretty enough. So I can use this letter T to make it pretty, and it's gonna make my query looking really good. So again, like if you're paranoid that your query doesn't look good, so you can put multiple spaces somewhere, you can put spaces here. So and if you want query to look neat, you just click beautify button. I think it's called beautify, and it's gonna make it look neat. Okay, so that's a very high level explanation on how to use the tool. So you can, when you open the database, again, like it opens up as just as a database name, but then you can expand it. So you can expand it to you can expand further down tables, and you can expand columns. If you want to see what actually sits in the database, you can open columns. We're not going to pay attention to indexes for now because we are going to cover indexes in a couple of lectures. But what you need to know from now, how to see columns in the database and how to see tables. So table list is here. Every table has columns, and you can just open the table and look what columns exist in this table. Right? So I think we are ready to start writing the queries. So I'm going to open two windows here. Let me minimize the presentation, and we're going to start working on queries one by one. So the way we're going to do it, ugh, come on. The way we're going to do it, I'm just going to go through examples here. So first example tells us we're trying to find all the invoices with total greater than $5. So where do I start? You've never seen this database before. You don't know what table contains invoices, and we need to show all the invoices. And here's an example of our SQL statement. So we need to select and then from, and then we need to use where clause. So in this case, I know that I need to select invoices, and I know that condition I need to select it under, I need to check for the total greater than 5. So let's look at the database schema. That is the second slide in this presentation. So um, here you go. I have a table invoices here. So let's look at the invoices table. Let's look what columns it has. It has invoice ID, customer, invoice date, billing address, billing city, and other four columns. So let's look at invoice table here. So let's open it up and see what columns this invoice has. And here's my total. That's the total that I need to look at. And I need to display all the invoices with total greater than $5. So I need to compare this total to $5 and my total must be greater. So how do I write this query? Again, there's two ways of writing it. I'm a lazy person, so I'm going to generate it. I'm going to go to query generator and I'm going to write select. And I'm going to see if I can actually make all right. Make sense out of what I have. So it tells me select all invoices um, with total greater than five bucks. So what data do I need from invoice? Since it doesn't tell me exactly what data do I need from invoice, I'm probably gonna start making my own choice. So I need invoice ID, invoice date. I probably don't care less about all this billing information. So I'm just gonna leave invoice ID data here. Invoice ID and invoice date. So what do you do for homework? Homework is going to be very precise. Homework is going to tell you exactly what fields you need to show, and it's going to tell you under what condition you need to show what fields. So there you will not need to guess. But here we're practicing, so we're just trying to see what kind of data we can get. So we have our select statement. We're going to select invoice ID, invoice date, and total. Now, from invoices, as you can see, SQLite by default is going to put semicolon at the end of the statement. Semicolon is needed when you're trying to execute multiple statements at the same time. In this case, you're trying to execute just one statement. So you can keep it, you can remove it, it doesn't matter. So I'm going to remove it and I'm going to write down the where clause. And in my where clause, I'm going to look at invoice total, where total, and I need total greater than 5. So I'm going to put the greater sign and 5. And here's my query. Okay, so let's try to execute it. Very good. So I got some data, and it looks like that my query executed finished in 1 to 1000 seconds. So looks like it works. Okay, so what else I need to do? I can make it pretty, so I can click T button. So as you can see, it changed a little bit the structure of the actual structure of the query here, so it looks good, right? So pretty simple. Now, let's try to find all the invoices with total less than 2. So this one is pretty simple. So we just need to modify greater than 5 to less than 2. And we're going to have a bunch of the invoices here too. All right. So that was number 2. Now, next thing is we need to find all the invoices placed after a certain date. So we probably need to find that it probably is going to be an invoice date. And this invoice date should probably be greater than 02, 03, 2009. So let me copy that date. I'm going to copy this date and I'm going to write invoice date greater than certain date. And if you deal with date, is always placed in single quotes. Depending on the version of your operating system, you might need to put it in double quotes. But so let's try to execute that. Okay. Here you go. I executed it. And it looks like I get really strange data here. So it looks like I still show invoices from January 1st of 2001. Um, so what can be wrong here? Let's look at the query. And again, like, I mean, when you execute a query, it's always a good idea to look if your data makes sense. Because in this case, query executed successfully, but my data doesn't make sense. I really wanted to show the data for invoice date that is greater than 0203 2009, but I'm still seeing invoices from the January 1st, which is incorrect. So what is the difference between what I'm putting in the date here compared to invoice date in the table? So as you can see, the format of the date in the table is a little different. They start from year, and then they have months, and then they have date. So my invoice date looks different. So I have months, date, and years. So maybe I need to modify the date structure. So let me try that. And again, just like I said, SQL is very needy. So sometimes you just need to look at what you're getting and make some analysis out of it. So here you go. So I modified the format. Let's see if my data will make sense now. Here you go. Now my data makes sense. So now I can see what I'm actually trying to retrieve here. Right. So that was number three. Let's move to the next one. And here are our answers. So the one for the invoice is kind of incorrect. So let's move on to the next one. So list first name and last name of all employees. Use column aliases, last name, and first name. So they're asking us to show first name and last name of all the employees. Let's look at the diagram. So we have employee table here. An employee table has a last name and first name. So we need to display first name and last name of all the employees um, without any conditions in their clause, but we also need to make sure that those have a specific alias because if you just display the column name, it's going to bring you exactly the same column name as it is in the table. So for example, back to this example with invoices, invoice date is the column in the table. See, there is no space between invoice and invoice date. And that is exactly how your query is going to bring you data unless you give it aliases. So let's try to execute this query against employees table. So let's go to generate a query and we click select and it's going to generate a pretty large query for us. So we don't need all of that. Let's get rid of the data we don't, the only thing we need is like first name and last name. So let's keep first name and last name, remove everything else. And again, like you guys can type, you can do query generator, it doesn't really matter. Okay, so I have last name, first name from employees. Let's try to execute that. Good. Query works. It looks like that query finished, so it's executed successfully. The only thing we're missing are aliases. The aliases they want us to use last name for last name and first name for first name. So we're gonna write it down as S. And then in single quotes, you might need to use double quotes or single quotes. It depends on how your specific SQLite studio is set up. Mine is a little old, so mine takes single quotes. Yours might take both double quotes or single quotes. You need to play with your editor a little bit. So let's give it an alias. An alias is how you want to name a specific column. So we want to give it a name last space name. So let's call it last space name. Okay. We also need to give an alias to first name. And we're going to say S and we call it first name. Okay. Good. Now Do you need to put it as capital? No, you can put it as lowercase. But when you click when you try to make it to beautify it, you click letter T. It's gonna make query looks pretty. So let's try to execute that. So as you can see in this last name, we have a space between last and name. So that means that our alias work. So if I would remove alias here um, and execute init common and execute query. See, my last name is column is going to look just like column in the table, so it's not going to have spaces. So aliases are used to make your output more readable. So let me go back. And here, similar to any other editor, I don't know what is the key in Mac, but in Windows is Control Z. So you can click Control Z and you can go back to your original query. So let's execute it again. So here we have a list with aliases. Okay. To the next one. So here are my aliases. Now, uh, we're gonna start using expressions here. So we need to display invoice ID, invoice date, calculate and display invoice handling fees as 10% of the total price for all invoices. All right. So again, what table I'm gonna be dealing with here? So I will need to look where to find the invoice data. So invoice data most likely is going to sit in the invoice table. And invoices table here, invoices table has multiple fields, so I know that I need to get data from the invoice table. Um, let me go to find, excuse me, find the invoices table, and I'm going to try to generate select query here. So again, a lot of data. I don't know if I need all of this data. So let's see what kind of data we need. We need to display invoice ID, invoice total, invoice date, and we need to calculate handling fee. So I need invoice ID, so I can get rid of customer. I don't need it. Invoice date, in total. So I'm going to get rid of the rest of that too. And also, I need to calculate handling fees. Handling fees is 10% of total. I already have a total field. So I just multiply total by 0, 1, and that would give me handling fees. All right, because 10% is the same as multiplying by 0, 1. So multiply by 0, 1, uh, and I'm going to give it an alias as handling fee. Okay, double looks like double quote works here too. So let me execute it. Here you go. Yeah, double quote works for me too. Okay, so I have an invoice date, invoice ID in total, and handling fee here is as 1% of the total. So I can actually look at the total as 119.98, and the handling fee is going to be 19 cents. So again, like make it if you want, make it pretty, so somehow it replaces it with square brackets. I don't know why, but I mean, here it is. So that's an answer for the first question for using expression. Um, let's do the next one. So standard shipping for non-US customers 9.99. Handling fee is 25%. So we need to calculate and display invoice total that includes shipping and handling fees for non-US customers. And we need to display we also need to display invoice ID. So first of all, um, we this data is going to come from the most likely from the invoices. But let's see. So they're asking us to calculate fees and fees based on total too. So As with the previous query, we're gonna start, you can modify this query, or you can start with a new one. So just for practice, let's start with a new one. Let's generate a new select statement. And in this case, we need to find customers who don't live in US. So let's look at the actual data in this table and identify what column we need to look at. So let's execute the query that brings us all the data in this table. So we have a billing address, we have billing city, and we have billing country. Here you go. So what we need to do, we need to limit our output for all the countries, but not USA. So in our where clause, um, we need to add a condition where country um, country is not equal to USA. Not equal is usually a greater sign and less sign together, but that's how we use it. So let's try to execute this query. And yes, we know we also need a lot of information, modify a lot of information in select clause, but let's try to execute this query and see if it actually works. Aha, it doesn't work. So what does it tell us? Because country is not in USA. So what is the problem here? I think we need to use it's incorrect no such column as country. Here you go. So it's not country, it's billing country. See, I made a mistake. I just typed country and I must type billing country. So if you look at the errors, you would clearly know what your error is. So let's fix it. So billing country is not equal to USA. Let's try to execute it now. Here you go. Let's look at the data. Let's see if we get any USA here, and we don't. Looks like our query looks correct. So again, guys, when you'll be writing queries, it's very important to analyze the data you get and see if you're actually getting what you expected to get from this query. Okay, so we got our data. Now let's see what we actually need to display. So they're asking us uh, to calculate handling fees, which is 25%. And we also need to display invoice total and invoice ID. So let's keep invoice ID, invoice total, because that's what we need, right? And let's calculate handling fees. So, and handling fee is going to be 25% of total. And of standard shipping is going to be $9.99. So they want us to calculate a display total that includes shipping and handling fees. So our total that includes all this information is going to be total, right? Plus 25% of total, right? 25% multiplied by total to calculate handling fees. And we need to add standard shipping, which is $9.99. So, and after we calculate all of that, we're going to give it an alias and we're going to call it total invoice price. Okay, so let's try to execute that. Looks good. Make it readable, and as you can see, when you make it, when you use letter T, it replaces single quotes or double quotes with square bracket. That's something new. I haven't seen that in SQLite in the past, but it works. It works. So again, tools change, so we need to adapt to those tools. All right, so that concludes this example. So let's move on. In the next example, we are going to try using aggregate function. So um, they're asking us to calculate the average total for all the invoices. So the function is called average. So we can again, like, I mean, start from scratch, or we can reuse this existing query. So I can maybe create another select query. So we don't need all this fun here. We can get rid of all this data. We only need total. And we just need to calculate the average total. And the average total is going to be AVG total from invoices. So here you go. The average total is $5 something. Looks good so far, but as you can see, the name of the column is not really pretty. So let's give it an ls. Let's give it an ls. Let's call it uh, average average invoice total. Okay, right. Looks better now. Cool. Next question, how many tracks album with ID 3 has? So we need to use function count, but we need to look at the tracks table. So let's see, what table do we actually need to look at? Let me make it a little bigger. So um, let's look at the data. So we have tracks table, we have albums table. So they're asking us what tracks, how many tracks album ID v3 has. So let's see. We're talking about tracks and albums. So albums has an album ID, which is a primary key, but tracks is on the many side of relationship. So tracks also has an album ID as a foreign key. Um, so most likely, since tracks has the tracks information, we need to calculate tracks for album ID 3. Let's calculate that. So we're gonna get the data from tracks for a specific album ID. So let's see the data. Yes. So tracks table does have an album ID, and we need to see data for album ID 3, I believe. Do we? Yes. Okay. So we need to find number of tracks for album with ID 3. Let's get let's generate a query for table tracks. So here we go. We have a lot of fields here. So what we really need to do, we need to count the records. So when we count the records, we usually use count asterisk. So we count all the fields. So we're gonna count asterisks and from tracks. And if you execute query like this, it's gonna give us the total number of tracks, total number of records in the track table. But we need to, we have a condition that we need to run this query under. So we need to find count only for a specific album ID. So in this case, we're going to add var clause. And in the var clause, we are going to type var album ID is equal to 3. Let's execute that. So in the count for tracks is going to be 3. Again, like, I mean, we can give count and ls as number of tracks for album 3. And we can execute that, so it's a little better, right? Okay. Moving on to the next query. Next one is going to be a little more complicated. So we're going to, no, not yet. So we're going to use like operators. So like operators allow us to compare approximate strings together. So in this case, they're asking us to find all genres with the name that starts from word rock. So where genres live? let's look at the database diagram and see where we can find genres. So genres probably live in the genre table, right? And genre table has genre ID and name, and we need to find all the tracks that has genre ID, genre names that starts from rock. So before we know that we need to work with genre table. So um let's run a basic query on it. So let's see how the data looks in genre tables. So we're going to run select, execute it, and we definitely are looking at the name right field. So we're gonna put name in the var class. So we need to find all genres with the names that starts from rock. As we remember, we are using when we use like operator, it's not the some very often it's not the exact comparison. So in this case, a like operator is going to use some characters. So when we're looking for something that starts from rock, it means that first four letters are going to be ROCK, but then it can be anything after that. So um, we're going to and we're comparing name. So we're going to write var name like, and we're gonna start it from rock, and then we're gonna put percent sign at the end. So percent sign means that we're looking for anything that starts from rock, and we don't care what is at the end of the rock. It can be anything that starts from this word. Let's execute that, and as you can see, we got results, and our results are correct. So our results looks like any albums that start from rock have the exact um, results here. So we have two albums. We have, I'm sorry, we have two genres. Genre one is rock, and the second one is rock and roll. That was easy. Okay, when you need to find something that starts, say, for example, with a space and rock. So you're looking at any characters that lay down before the rock, and you know that it's going to be only one character, right? So you put underscore here, and underscore means only one character. It can be any character, but it's just one. When we're talking about many characters, we can put a percent sign. So technically, one is a subcase of many. So if you are not precise about what you're looking for, it's always a good idea to put percent sign. All right. Moving on to the next one, Boolean operators. So we want to find all the invoices that are placed after a certain date with total less than $2 and all US invoices. Right. So, well, we know pretty good that we're going to select data from the invoice table. But remember from the lecture, when you deal with Boolean operators, it's very important to have the correct order of operations. So in this case, we need to find all the invoices that are placed after December 1st with specific total that is less than $2. In addition to that, we also need to find all the invoices that are shipped in US. Okay, with bill and address shipped to US. Okay, so we are going to start from the invoice table. We are going to generate SQL statement from the beginning, and we'll have a SQL statement that has all the columns here. So um, we will keep invoice ID, invoice date, maybe total. We don't need more information here, but all the logic is going to be, they don't tell us exactly what columns they want us to replace. So in this case, I mean, I'm making a couple of guesses here. So I assume like invoice ID is going to be helpful. Invoice date is going to be helpful. You can, if you want, you can select all the fields. It's also not going to be a mistake unless otherwise stated. So let's try to just select everything. So asterisk stands for everything. Now, um, big deal is with very close. So here we're gonna start writing a lot of different conditions. And when we write multiple conditions, it's always good to, again, I'm lazy. I love using table aliases. Remember, we used column aliases when we try to display data. In this case, I'm going to use table aliases. It doesn't really matter what name you're going to give it. I'm going to give it the name I, and then next time I'm going to be typing something, I can use that as an alias, and it's going to give me a complete drop down of the tables, of the table columns. So let's start writing the very close. So where we need to find all the invoices placed after a certain date. So it's going to be I dot, come on, why my ls doesn't work. Here you go. So I'm going to select invoice date here, and invoice date should be greater than 2013 December 1st. So I'm gonna copy it here to eliminate mistakes. So greater than um we also I also need to make sure that those invoices that I'm finding have total less than $2. So it's going to be I dot total. Come on. And I dot invoice total is going to be less than 2. Um, and in addition to that, I also need to find all the US invoices. So I have this data set, but I also need to add another data set. So it's going to be those two conditions, invoice date greater than 2013 and invoice total less than 2. But in addition to that, I need to add or statement or um, invoice US US invoices, meaning billing country needs to be equal to USA. So, and how do I know that? We already worked with billing countries, so I know that billing country is USA, so I'm just going to add a condition here, or billing country equal to USA. Okay, so let's try to execute that. What does it tell me? No such a columns billing country. My God, I'm always making a mistake with this billing country, so I'm missing letter G. Okay, so that should work now. Now I should get the data with the invoices that are placed after a certain date, and that is true here. And also, invoice total should be less than $2. So my first result is not correct here, but why this result is included in my result set? Because I'm also looking for USA invoices regardless of what is total and what is the invoice date is. So if I scroll down and looked for non-US invoices, those should only be placed after December 1st of 2013, which is the case here. And the total should be less than $2. And that is the case here too. So as you can see, this query looks like it brings me correct data. And again, I don't need to analyze everything. I just need to take a brief look at the data that I have and make sure that it's actually a correct statement. A lot of questions I get, why do we use or here? Because even though we need to find, even though it states here, and all US invoices, if we're gonna use and in this query, it's going to give me invoices placed invoices with a billing country equal to USA that are placed after a certain date with a total less than 2. But I need to get all US invoices regardless of the first two conditions. So that is why I use letter or here. Again, if I'm going to use letter and, if I'm operator and, if I'm going to use operator and here, I will, all the three conditions is going to be used together. But that's not what I'm looking for. I'm looking for invoices placed after the certain date with total less than 2. In addition to that, I want to see all invoices placed in the United States. Okay. All right. So here's our example. So is null. Is null a super simple concept. So we need to find all the invoices with bill and state is set to null. So let's start from the invoices again. We can generate a new query. We can put select statement here and we need to find invoices with the bill and state set to null. So we can get all the invoice data. It doesn't really matter because they don't tell us specifically what they're looking for and select close. So in where close, we need to find bill and state equal to null. So we're going to get bill and state. And set it to equal and use null. So that should give me all the data with null. Surprisingly, I don't get any result set back, and it looks like I have correct data. Well, what should I do here? I just used equal sign to null. What I should do, I should type is null. Is null should get me more data. So see, equal to null and is null is not the same thing. So is null operator is going to bring you all the data where the bill and state is null. So see, like, I mean, all the bill and states here are null. Right, so equal to null and is null, those are two completely different things. Well, they hypothetically supposed to bring us the same results, but not in SQL. SQL is needy, and the sequence, the syntax for finding null data should be is null. All right. So next one is between. So the way we use between is it's a good operator, but it can only be used with numbers and date, no strings. So again, we are looking to find the data from the invoice table. We're gonna click generate the query for the invoices, and we are going to add where clause. And in where clause, we'll be using total between 1 and 10. So it's going to be total between 1 and 10. Pretty simple. Between is incorrect. Between. Here we go. All right. So let's execute that. And let's look at our total. So, and our total looks like it is indeed in between 1 and 10. So that's your between statement. Right, next one. Next one, distinct values. So when we're trying to find distinct values, we're trying to find the unique list of values, and they're telling us find all unique billing codes from an invoice table. So when it comes to distinct values, null is going to be included in the results. So we are looking for a specific distinct values for postal codes. And since they tell us that we'll be using invoice table, we already have a query for invoice table. So we don't need a where clause, so I'm going to get rid of the where clause here. And we are going to find distinct billing postal code. So distinct billing postal code, we don't need total. So that should do. Here you go. So you have a bunch of distinct postal code. You also have nulls because remember we talked that distinct is going to bring you null values too. Next one, in and not in. Those are operators that are used primarily with the list of strings. So here we need to find all customers that reside in US, Canada, and Brazil. So customers most likely gonna live in the customer table, right? So let's see what columns customer table has. So let's execute the query to see like the actual data in the customer table. So customer table is going to have like customer information and um, customer table has a country. So that's probably something that we will be working with. So when we create a list of countries, we put it in where clause. So in this case, it's going to be where. And we know that we need to compare country column to that. So country in, and parenthesis here, and every country should be in quotes. So USA, uh, Brazil, Brazil, and what else? Canada, right? When you're writing queries, you need to be pretty specific on what you're doing. See, like once and when you see like some red underline means there is something wrong with the syntax. In this case, I missed parentheses, so once I edit, it's all fixed. So let's execute that, and that should give us only data for US, Canada, or Brazil. And that's what we get. So when we look at the data, I mean, that's exactly what we get. Now, um, next one, find all the customers that do not reside in USA or India. So in this case, we're going to use not in, and we will modify this query saying not in, and we add India here and execute. Here you go. So now we have countries. We have countries, all the countries except for United States and India. Okay. Uh, in, not in, done that. So order by. Order by clause allows us to sort the results. So we need to find all the customers who reside in USA, Canada, and Brazil. Order results by country descending. So let's go back to the query that we had. Remember, like Control Z in Windows is very powerful too. So we can go back, and we have our query that we wrote for USA, India, and Brazil. Now, this query is going to work, so the only thing we need to do is add order by. We're going to add order by clause and order by country descendant. So in this case, order by country, and we need to order descendant. Okay. So that should bring us the same list, but ordered by country in reverse of the alphabetical order. So it's going to start from countries. Where is our country? State, country. Here we go. It's going to start from United Kingdom, and then slowly and surely it's going to get to Australia and Austria. Cool. So we're done with those. Let's see what's next. Next, we're going to learn how to use group by. So we need to find number of customers in USA, Canada, and Brazil in each state. So we already have a query to find find the customers in USA, Canada, and Brazil, and it's already ordered by. So we can get rid of order by. We really don't need this clause. I mean, we can keep it, but we don't need it. Now, what we really need to find is a number of customer per state within specific countries. So we keep this very close, and we also want to display state probably, right? So let's keep state here, and uh, let's count our records. So we're gonna count asterisks. Now, this is great. And let's give it an alias here. Is customers, cust, custom, customers per. Now, uh, comma. It's all good. Except for, remember, when we went through the lecture, I told you that if we add any other condition to the aggregate function, we need any other column to the, in addition to aggregate function to display, we need to group by this specific column. So in this case, we have an aggregate function count, but state is not part of this aggregate. So we need to add a group by this specific column, in this case state. So we're going to group by state here, and we execute that, and it should give us the number of customers per state in all the countries except USA, Brazil, and Canada. Okay, so it's your results for the group by. Right. Yeah, and we when we use a group by, order by always goes as the last state. So in this case, I removed order by, but when you need to add order by, it always goes as the last one, last statement in this case. So in this case, we can add order by. It's going to be order by, and we can order by, and we can order by state, country, descending. If we want to display country too, we can add country to the list. So, and again, like if we add country to the list of displayed field, we also need to add it to the group by. So we can add country here too, and now it's going to show us countries, and it's going to be grouped by state and country. Right. So remember, every time when you have a group by clause, you always add order by is the very last statement. So order by allows us to sort the results. So whatever we do before order by is going to be our final query, and order by just helps to display result in sorted order. And again, if we are sorting ascending, we don't need to specify it. If we're sorting descending, we need to specify how we sort. And the last one is having clause. So having clause works as a where clause, but on aggregate. So having clause works on a group by expression. So in this case, they want us to find states in US and Canada with a number of customers greater than 2. So, well, we need to count customers per state. We already have that. We have state and country. Now, we just need to only show those states that have count of customers greater than 2. So, in this case, we just need to add having clause. Having clause here, having total, oh, having count of customers greater than 2. And again, having only works on aggregate. So every time you have a group by, but then you need to further limit the result set, you use have clause. If you don't have a group by, you don't need a have clause. Have only works with group by. If you have non-grouped expressions that don't need to use any aggregate functions, so you just can use where clause, and have clause is not needed. When you, just like I said last time, when you write a query, order by always goes as a last statement in the query. So in this case, if we execute that, we are only going to show the countries with a count greater than 2. So as you can see, like, I mean, in the previous one, we didn't, we had much more countries in here. So I want to show you a couple more cool things. So say, for example, you're working on query and you need to see if the actual query works before adding some conditions. Or say like you have a lot of work done in the query, but you don't know what works, what doesn't work. You can comment. You can comment some portions of the query. So for example, let's see if I can select customers. Um, Yeah, in this case, I also need to comment count. So in this, let's try to see if I can select state and country from customers order by country descendants. So I can execute that. Okay, now I can add count to that. But again, like when we have count, we always work on a group by. So I can add back group by and I can execute that. And again, like this works. So I can uncomment very close to see if very close works. And again, like if this all works, I can add have close. That is a very neat tool for you guys if you work on the large query and you don't know what part of this query works, what doesn't. So you can always comment, and comment is just 2 dashes. Okay, so in your homework, I'm gonna ask you to use comments to put your name and the question number. So the way you do it, you add 2 dashes and you add your name, for example, my name, and then you can add the question number. So for example, question 1. And then you can add a couple of dashes so I would know that you're the one who types this query. And you execute it, and everything that is used in the comment section is not going to be part of the query. Okay, so that's all I got for you guys for this lecture. It's kind of long. It gets got longer than I expected, but that is our first part of SQL. I hope you like it more than diagrams. I love SQL. It's amazing database language. So if you have any questions, let me know. I'm available to help. And next week, you will start working on homework 2. Homework 3, I'm sorry.